A warm welcome to all of you. Today we are going to learn about the new concept in our programming about array function. Arrays are the data objects which can store data in more than 2 dimensions. Example, if we create an array of dimension 2, 3, 4, here the first two will speaks about the number of rows, and the second value the number of columns, and the third value such kind of 2 by 3 matrices how many we require. The 2 by 3 size of a matrix I required 4. The 2 by 3 size of a matrix required 4. So the first number, it tells about the number of rows, and the second number the number of columns, and the third number the number of matrices in an array. Then it creates 4 rectangular matrices, each with 2 rows and 3 columns, and such size 4 matrices will be created. 4 matrices will be created. Array can store only one data type. Arrays can be created with the help of array function. The function has to be defined like this: array and the brackets. The syntax of an array creation: a variable name followed by the left assignment operator. We need to call up an array function. In the array function, we need to include the data and the dimension and its specification. The dimensions will tell us about the number of rows and the number of columns and the number of matrices and the dimension names. Suppose we can give a dimension names like this: rows R1, R2, R3, the columns C1, C2, C3, the number of matrices, matrix 1 and matrix 2. So this is what the basic syntax of array function in R programming. The data need to be specified and its dimensionality has to be specified. The number of rows and the number of columns and the number of matrices we require, and the dimension and its names. So we have to specify like this. And as we see, the data stands for whatever the input that we are trying to give in the form of a vector, where the values in an array, the values in a matrix, the values in a matrix that we are trying to give in the form of a vector, and row stands for the number of rows, and columns the number of columns, the matrices the number of matrices we require, and the dimension names speaks about the names for the rows, columns and matrices. Now we will create an array with the help of an array function in R programming. See here, the name of the variable A. With the left assignment operator, I am trying to assign the output of array function into a variable, and now I am calling an array function array and followed by a vector function, a sequence of numbers from 1 to 9. 1:9 stands for, it will call for the sequence of values from 1 to 9, and the dimension will tell us about, it is a 3 by 3 matrices, which tells that 3 rows and 3 columns. So such kind of matrix I required 2. Such kind of matrices I required 2. Now I will try to execute this particular code. Now I want to run the created variable A. See here, there were 2 matrices were created, the matrix 1 and matrix 2, and it is a 3 by 3 matrices because 3 rows and 3 columns included in both matrices. If I do not specify the dimension, so what will happen? If I do not specify the dimension, so just execute this code. Let us see what will happen when we do not specify the dimensionality of an array. So it will print output like this. So it will give you like a vector output. So it will give you like a vector output. Now the next, I would like to create one more array by the name of variable name B, the name of the array B. With the left assignment operator, I would like to call up an array function. In array function, a sequence of variables from 1 to 20 with C vector function. With the dimensionality, I required 3 by 3 matrices. 3 stands for the rows and the next 3 stands for the columns. So this kind of matrices, I required 2 matrices. Now execute this particular code. Now when you run this, so what will happen is actually we are taking a sequence of numbers from 1 to 20, right? And here you can see the arrangement was happened on the basis of column wise 1, 2, 3, 4, 5, 6, 7, 8, 9, and the continued in second matrices 10, 11, 12, 13, 14, 15, and 16, 17, 18, and automatically the remaining 19 and 20 will be left. So that's how we can able to create an array in R programming. Now, when 3 matrices inputs are different, then how to create? When 3 matrices and its inputs are different, so it's very simple to create. Now we need to specify the variable name, the name of the variable D, and with left assignment operator, we need to call up an array function. Inside of the vector function, we need to specify the sequence. We need to specify the sequence. In the first matrices, I want to include 11 to 14 sequence of matrix, and in second matrices 21 to 24, in third matrices 31 to 34. Now if this is what the output that I am expecting, now the dimensionality, it is all about 2 by 2 matrices. It tells the first 2 stands for the number of rows and the second 2 stands for the number of columns. Now by like this 2 by 2 matrices, I required 3 matrices. I required the 3 matrices. So execute this code and execute the created variable. Now you can see here the elements in the matrices are not the similar. So the first matrix comprises of 11 to 14, the second matrix comprises of 21 to 24, and the third matrix is comprised of 31 to 34. It is not in a sequential order. So whatever the sequence that we want, that we can able to specify here. And the dimensionality, it is a 2 by 2 matrices, and such kind of matrices I required 3 number. If that is a situation, we can create like this. Now in next concept, what I would like to tell you is how to add row names, column names, and matrix names in the array function. So how to add the row names, column names, and matrix names. So for this, what we need to do is explicitly, first of all, we need to create 3 different kinds of variables by specifying the row names, the first variable and its name, the row names, and here we need to create a vector function. So we need to specify R1, R2, R3, and the second one, column names. So execute this particular code. So I created a variable by the name of row names with a C vector function, and the column names C1, C2, C3, and matrix names matrix 1 and matrix 2. So what I try to do here, explicitly I created 3 different kinds of variables: row names, column names, and matrix names. So in next step, what I'm trying to do is I'm trying to pass these created variables outputs into a new variable that I'm going to create with row names and column names and matrix names. So here I'm trying to create a new array. The name of the array E, and I would like to call up over here an array function. So the sequence of variables includes in vector function 1 to 9, and its dimensionality 3 rows, 3 columns. This kind of matrices I required 2. So these kind of matrices I required 2. So for 3 by 3 matrices I required 2, and the dimension names that we need to specify in list, whatever earlier we created the dimension names. So row names, column names, and matrix names. So these row names, column names, and matrix names, explicitly earlier I created 3 different variables here: row names, column names, and matrix names. So I'm trying to pass the output of these 3 different variables. I'm trying to pass into a new variable that I'm going to create over here with the help of the name of the variable E. So we need to write a command over here like this. So run this. Now round the array. Now you can see here earlier. Now this is the matrix 1, the name of the matrix 1, the name of the second matrix 2, and the column names column 1, column 2, column 3, the row names row 1, row 2, row 3. So it is being created like this. So that is how we can be able to add the names of matrices, row names, column names, and matrix names. Okay. Now the next concept, accessing the elements from the matrix. So accessing the elements from the matrix. Suppose if we want to access second row, third column of the second matrix. Now suppose I want to access a second row and third column from second matrix. Now execute this code. Now it will tell you its number is 8. The second row and the third column from the second matrix, it is 8. It is 8. And to access third row and third column from the second matrix. So here that we need to understand very clearly, 3, 3, 2 stands for first number, the first value it is row, the second value it is column, and the next value it is the matrix. Either it is a second matrix or first matrix. The first 2 values, it speaks about the size of the matrix. Right? So the first value, when we are trying to extract the data from matrices, the first value speaks about the row, and the second value speaks about the column, and the third value speaks about the matrix. So first 2, it speaks about the size of the matrix. The first 2 speaks about the size of the matrix, and the last number speaks about whether it is a matrix 1, matrix 2, or matrix 3. Right? So execute this particular code. So it is 9. And even to access third row of first matrix, Suppose if I want to access only the third row of the first matrix, we should be very careful when we are trying to perform this. So 3 comma comma, the next second comma speaks about I don't want to see any output related to the column. I don't want to see any output related to the column. I want to make it empty. When you are trying to make it empty, you need to put comma, right? And from first matrix, and from first matrix on this. So this is the, you know, the third row from first matrix, but I didn't specify any column over here. So if I want to nullify the column, so we need to just put comma, that is enough. And to access the second column of first matrix, to access second column of first matrix, so first we need to nullify the row, so just put comma, and the second number 2 stands for the second column, the second column from first matrix, from first matrix. So this is what. Now to access third and third row and third column of 2 matrices. Now this is important aspect. To access third row and third column from 2 matrices, from 2 matrices. So what we need to do here in the sense, so you just specify so matrix 1 and matrix 2, you know, third row and third column of 2 matrices, the values are 9 and 9 because my 2 matrices are same. And to access second row and the second column from first matrix. So if when you want to access the elements from second row and the second column from first matrices, that we need to execute this particular code. It will come like this. And the next one, to access first row and third column of first matrix, the first row and third column of first matrix. So how to execute this? The next, to access second row elements of 2 matrices. When you want to access the second row elements of 2 matrices, second row elements of 2 matrices, so just nullify the column and nullify the matrix number also, then automatically it will give you, when you are trying to access the second row elements of 2 matrices, you need to just give comma over there. Don't specify anything, just nullify by giving comma comma, then automatically it will be printed like this. Now suppose to access all elements of first matrices of 2 matrices, suppose to access all elements of the first row matrices of 2 matrices, then you can able to give. So we can see here, you can get the output like this. Now we will see how to perform different operations in arrays. Suppose here I created the name of the variable. Suppose the syntax, how to perform a different operations in arrays. The variable name followed by the left assignment operator, apply, and array name, and we need to use here a vector function 1 or 2. Here 1 means rows and 2 means columns. Here 1 means rows and 2 means columns. Suppose what I want to do is I want to create a variable by the name of array1. With left assignment operator, I want to call up apply function from matrix A. I want to see from matrix A in first row what is the maximum value. From first row, what is the maximum value? That is what the code over here. So be very careful when you are trying to execute this. So I'm trying to apply the function of apply function here. From the first matrix, from the A matrix, from first row, what is the maximum value? From first row, what is the maximum value? Comparatively, what is the maximum value? Execute this. Now execute this. So here the first maximum value is 7 and the second maximum value from second row it is 8. The third maximum value from the third row it is 9. As you can see here, see here, from the first row, the first maximum value is 7. And from second row, the maximum value is 8. From the third row, the maximum value is 9. It has been shown. Very clear. Right? Now, find the minimum element of columns. So I would like to create one more variable, array2. With the left assignment operator, I want to call up an apply function from the array A. From second column, what is the minimum value? What is the minimum value? From column operations, what is the minimum value? Just execute this. So from column operations, from the column operations, the minimum values are 1, 4, 7. From the column operations, the minimum values are 1, 4, 7. Suppose here we can see the created matrix, the column operations. In column operations, what is the first minimum value is 1. From second column, the minimum value is 4. From the third column, the minimum value is 7. So 1, 4, 7. From the column, so 1 stands for rows, 2 stands for columns. And find the matrix elements of column. And from columns, I want to extract the maximum element. From the columns, I want to extract the maximum elements. So I created one more variable here. The name of the variable array3 with left assignment operator. I want to call up a function apply from an array. From array of A, the column operation, what is the maximum value? What is the maximum value? So the maximum value, I try to execute this. So the maximum elements are 3, 6, 9. So because we can see in the created matrix, in the first column, the maximum value is 3. In the second column, the maximum value is 6. From the third column, the maximum value is 9. So that's how we can able to perform in the column operations. We can perform the maximum, minimum. In the row operations, we can perform the maximum and minimum. Now the next, what I want to show is attributes in array operations. So the attributes is a function which is used to extract the row names, the column names, and the matrix names. So attribute is a function which is used to extract the row names, column names, and matrix names. The syntax to create a matrix: attributes of variable name. So I want to check the attributes of the created variable E. See here, the row names are R1, R2, R3. The column names are C1, C2, C3. The matrix names are matrix 1 and matrix 2. So that's how we can able to perform the attributes operations in array functions. So these are the various operations that we can able to perform in array functions. So we can able to create an array, and that we need to specify the dimensionality, which plays a prominent role. The first number speaks about the number of rows, and the second number speaks about the number of columns, and the third value it is the number of matrices. And when you do not specify a dimension, it will print like a vector. And when you want to repeat, you can repeat in the arrays the number of matrices. When you want to create the matrices with different values, that you need to specify in vector function. The sequence that we need to specify in vector function, the dimensionality need to be specified. And when you are trying to create the row names, column names, and matrix names, so explicitly we need to create all these names. Later on, we need to pass into an array. So I hope you understand this session.